Hello, in this video I'm going to talk about how to make Lewis structures for ionic compounds. As a review, ionic compounds are formed typically when a metal bonds with a nonmetal and there's a transfer of electrons rather than sharing of electrons, which happens with covalent bonds. So I'll just give you a general idea of how it goes with this first one. We've got KCl here. That's potassium. K has one valence electron. Cl, if you look on the periodic table, it has 7 valence electrons. And so here's what's happening. Cl wants one more valence electron so that it can be like a noble gas. In this case, so it can be like argon. And potassium's actually all right losing that valence electron because potassium wants to be like a noble gas as well. And if it loses one, it goes to being like the noble gas which comes right before it, which in this case is argon as well. So it's going to transfer its electron to that chlorine. And so what we get in the end is potassium with no valence electrons on it, which is really like having a full shell on the layer below. All right, and then we've got chlorine, which has 8 valence electrons on it. And in this case, they're both pretty happy because they're both like noble gases. Potassium losing one becomes like argon, and chlorine gaining one becomes like argon, and so they're both good. The one last thing you need to do here, though, is because chlorine gained an electron, it's negative because electrons are negative, and potassium gave up an electron, so potassium is positive. All right, so that's how that one goes. Number 2 here with MgO, it's very similar. All right, first of all, magnesium, Mg, has 2 valence electrons in it. Then we've got oxygen. Oxygen's got 6. All right, and what's going to happen here very similarly, the oxygen is going to give, the magnesium is going to give its electrons. It's the metal usually that gives the electrons away, all right, to the nonmetal. So magnesium gives up both of its electrons. That makes magnesium become like neon, and actually, again, oxygen is like neon in this case. They're not always like the same noble gas. It's just kind of a coincidence, these first two, that they ended that way. But when you have magnesium with 2 less electrons, it becomes like neon, all right, and it takes on a 2+ charge. All right, if you have oxygen and it's got an extra 2 electrons, it becomes like neon, and it has a 2- charge. Okay, going down here to AlBr3, aluminum has 3 valence electrons. So I'm going to give myself a little bit more room on this one. So aluminum has 3 valence electrons on it. And then we've got some bromines, 3 of them that we're going to throw around here. And so what's going to happen is this aluminum, again, it's the metal, it's going to give up its electrons. It wants to be like neon. If it loses 3, it will be like neon. So it's going to give them up. Bromine wants to gain 1 electron each so that it can be like krypton. All right, so this aluminum is going to give 1 electron to each of these bromines. All right, and what we end up with here is aluminum is in the center. It's got no valence electrons on it because it's given them away. And then along the outside of it, we've got a bunch of bromines here. Each one of these has a negative charge because it took on an extra electron. And then the aluminum is 3+ because it gave away 3 electrons. Alrighty, that is that. Ca3N2. So this one, we've got 3 calciums and 2 nitrogens. I kind of recommend that you stagger them or go back and forth. So we're going to say Ca, and then N, and then Ca, and then N, and then Ca. In terms of the electrons here, calciums have 2. Nitrogens have 5. So each nitrogen should have 5 on it, each calcium should have 2 on it. Okay, so here's how this is going to work. This calcium is going to give both of its electrons to the nitrogen, and then this calcium is going to give one electron to this nitrogen, and its other electron to this other nitrogen. All right, and then this calcium is going to give both of its electrons to this nitrogen. So the side ones gave both of theirs to the nitrogen that were next to them. The middle one split up between the two. But what we end up with here is calcium with a 2+ charge, and then nitrogen with 8 electrons around it, which has a 3- charge. And then we got another calcium with a 2+, and then another nitrogen, 8 electrons around it, 3- charge. All right, and then another calcium, no electrons around it, it's a 2+. All right, and that's what that one looks like. That's about as hard as these get. Okay, so now I have some for you to try here. I'll go through and do them. We've got LIBR, so Li has 1 valence electron, Br has 7. All right, we saw an example like this before. This Li is just going to give its electron to the bromine, and what we end up with here is Li plus and bromine with 8 electrons around it, minus. All right, Na2O. Here we have 2 sodiums and an oxygen. I'll put its 1 valence electron on there for the sodium. For oxygen, I'm going to put its 6 valence electrons on there like this. I'll put the other Na on this side. It has 1 valence electron. And so what's going to happen here is the sodiums are going to give their valence electrons to the oxygen, and we end up with Na plus, and then an O with 8 electrons around it, which is a 2-, and then another Na plus. Okay, here on the bottom, CaS. Calcium has 2 valence electrons. S has 6 valence electrons. The calcium is going to give its electrons to the sulfur. All right, and what we end up with here is Ca2+, and then S, 2-. BAF2, all right, so on this one I'll kind of stagger them again. There's 2 Fs, so I'll put them around the outside. Each fluorine has 7 valence electrons. Barium has 2 valence electrons. What's going to happen here is the barium is going to give 1 electron to each of these fluorines. All right, and so we end up with 2 of these Fs, which have a -1 charge and 8 electrons, and the barium is in the middle. It has no electrons around it. It has a 2+ charge. All right, and that is that one. We have just a couple more examples here on the back. All right, so here we've got 3 cesiums and a phosphorus. Cesium has 1 valence electron. Phosphorus has 5. So what's going to happen here is the cesiums are going to give their electrons to the phosphorus. All right, and what we end up with here in the end is 3 cesiums which are positively charged around a phosphorus, which has a 3- charge. All right, and then one last one. This is like that really complicated one where we had at the end. We're going to stagger these. So strontium which has 2 valence electrons, and phosphorus, oops, phosphorus, which has 5 valence electrons, I keep putting these electrons on an inefficient side. I think if we're going to give phosphorus 5 valence electrons, we should leave the 3 open ones on these sides so that the metals can give them the electrons. Because, like you'll see in here a second, strontium there. This P, I'll do the same thing too. And then this strontium, this 2 valence electrons. Okay. The reason I line them up is just for efficiency. Like this is going to go over here to this one. This electron is going to get transferred here. This electron will get transferred here. And so I just want the electrons to be in the right places so that they transfer efficiently with the arrows. It actually wouldn't be wrong if you wrote an arrow that went all the way around something and then just said where it ended up. Then the strontium is going to give both of its electrons here to the P. And what we end up with is Sr2+, and then a P with 8 electrons around it, which is 3-, and then Sr2+, and then a P with 8 electrons around it, a 3-. All right, and then one more Sr2+. Okay, so that's that. I think that this is actually quite a bit less complicated than the Lewis structures for covalence, but make sure that you get a handle of this, and if you have any questions, make sure that you come in and ask.